What's up people, and welcome to the 7th part of my Introduction to Distributed Systems tutorial. So in this video we're going to dive a little bit into failure detection and what that means. So if you remember from the demo, we have a failure detector that, for example, when I kill one of the nodes like this, we discover this at the other nodes. Basically, this is what a failure detector is about. So this is saying that I should probably remove this node from the topology because it seems to be dead. The important topic here is that it seems to be dead. It is suspected at this point, because in a asynchronous network we cannot know if it is actually dead or if it is just really slow, because we don't have any upper time bound for knowing how slow it is. So it might just be slow, and now it's back again. So okay, it was just slow. So now it is no longer suspected. And if you have the book, you can go to page 55, and you can check out this implementation. And this is kind of what I did in the application that we're using here. So I'm going to go through this here. And like in terms of convention of how the book is written, you have P, which stands for a failure detector. The diamond here means that it is eventually a perfect failure detector, P. And so this is what this is implementing, and this uses a perfect point-to-point link. It is assumed you can check out in the book what this actually means, but like in our occasion, it has the perfect point-to-point link has some guarantees like FIFO ordering and stuff like this, but the interpretation of this is TCP connection with resends if it loses connection. We use HTTP in the application, so we have TCP because HTTP implements TCP. So when the application initializes, this is what it do. It has the alive set. It sets the alive set to the set of all processes, so everybody is assumed to be alive as the initial state. The suspected set is set to the empty set, so basically no one is suspected. The delay is set to some small delta value, and then you start your timer with this delay that we set to the delta. So whenever you receive a timeout, so basically it is assumed that you're doing incremental pulse and pings to the other processes, right? So when you get one of these timeout from the ping, you check like you take the intersection of the alive and the suspected, and if that is not equal to the empty set, then you increment the delay with this delta value that you have set here, right? So what this means that it is, if it is alive and it is not in the suspected set, that means that okay, you know what, he wasn't dead, so increase the delay. So then for all processes in the all processes set, this is what it does basically for each process. If the process is not alive and the process is not suspected, then you add it to the suspected set, and then you trigger the suspect event. Basically, this is what we see here, like I should remove blah blah blah. If the process is alive and it is in the suspected set, then basically, so it's alive, but it is also in the suspected set. That means that it shouldn't be suspected, so you remove it from the suspected set, and then you trigger a restore. In the application, we don't see the restore. We just see that it's just stops printing that it should be removed, and this is what happens here. It's getting removed from the suspected set, and then what you do is you send the heartbeat request. Basically, you ping everyone, and the alive set to the empty set, and then you start the timer of the delay. Whenever you receive a heartbeat request, you just reply, and whenever you receive a reply, then you add it to the alive set, basically. And this, if you want to check out the actual implementation of this in the source code, you from the root project, you open the node folder where everything in the source code is, I think it is in the failure detector folder, and here index. So what this does is basically just holding the suspected set, some function for checking if someone is suspected. You have the restored. You can also get all the suspected nodes. If you check out the broadcast implementation that we have in the bottom here, you can see that we have a cron job running. This says that every 5 seconds you run this pinger thingy, and then you, from the topology manager, which we will talk briefly about in the next video, you grab all the nodes basically, and then you broadcast the ping to them. On the receiving part of this, you see that we have this ping message here. Let's see. Oh yeah, let's see here. So it receives the topology. What happens here is, I don't want to get into this, but because we will talk about this in the next video. But we check here when you receive a ping. If the message that you received here is in the suspected set from the ping that you received, then you do a restore. And here we do the thing that we talked about, like if your clock is behind, then you need to catch up. So then you ask for the data that you're missing. But that is covered in some of the next videos. So hopefully that was understandable in terms of what this failure detector does, and in general how a failure detector is put together. The only thing that is missing here is when it is removed from the suspected set according to the algorithm, you should increase the delay, because you don't have, your delay is too short basically, because it says that it is alive and it's like in the suspected set and stuff, so you should be increasing your delay here. And I don't do that because I want to have a little bit too short delay so I can test it properly. Alright, so I hope you guys enjoyed this video, and I will see you in the next one. See ya, bye bye.